Yes, hello everybody. This is Arimo Koivisto, and we are today presenting Privecall TX project. And this is something that we started a few years ago, and we are here today to tell about what is this project all about, what are the fundamentals where it started, what we have done here, and what we are aiming. And it's really nice to have this moment with you to share this information and project. I have my expert from our team here who will detailed tell about the background of the project, why we started this, and what we have actually done with the mobile device. So it's quite nice device and sort of unique also that we have been able to create here. But all right, so let's start.
Yeah, hi guys, and we try to give you some little bit different story about the communication security and how it's done in the real world, and how it's actually done in a way that you can actually believe what you are doing and you know what you are doing. And of course, our background is presented on this slide. So we are a team of the Linux engineering guys with bit of the background from the cryptography section, heavily involved with OPSEC experiences from various environments and places that we've been doing this thing. And we have been having some really unique view inside of the interception systems and things like that. So we kind of believe what we are actually talking about here. So the story is a bit of the different what you have seen so far. So that's actually the question that I would like to ask from everybody today, that how actually you secure your mobile communication. And this is the question that actually we faced, and when we started to find out the ways to do it, it was not that easy at all. So this is the most typical thing, that you actually turn your eyes into something that is already there and it's been working like tens of years, or it's something new and emerging technologies, but still this was something that we were not interested about. So basically what we did, we actually came out from the consumer domain in that sense. And this is actually the reason. So basically there is this consumer domain devices, they kind of have a lot of applications, a lot of actors doing the code in the devices, and there are a lot of applications running. But for us, they have always been known unknowns. So you know that there is something shady in the device or the system, but you don't know what it is. So it's kind of declared to be known unknown in that sense. And basically, it also means that since we cannot actually know what happens inside of our memory, how the computation is done in the way, what is the communication channels, who is actually handling your input and output devices, and the persistent storage is kind of on playground of all of these different applications and vendors and code signers and operating system providers. This is something that we kind of knew that it's totally impossible to do anything secure in this domain, and it's kind of interesting to think that, okay, if I have my super secret app running on the iOS device or the Android device, and this super secret app is supposed to secure my communication, and on the same time you actually share your memory bus with the devices, and you kind of have to trust that you are keeping your secrets in the code and in the storage and in the runtime. So for us, this was an untrusted environment for the encryption, and this is something that we came to solve with the Privecall TX product, and it's kind of addressing these problems. So currently the mobile landscape, this is interesting. This is the complicated slide, but it gives you some sort of idea that what happens in the mobile communication in the consumer domain. You have the consumer devices on the left side of the picture. There are a lot of inbuilt access vectors to those devices. There are a lot of shady things going on in the device sector, and of course there is a mandatory cloud involved in all of these. And part of these device issues are planned and designed. Some of them are accidents, and some of them are something that you just cannot control the device. But then on the other hand, the network is the same situation. There are a lot of access vector in the network, and mostly they are coming from the fact that there is actually the legal way to intercept the traffic on the network, and running the encryption in the consumer device. It's probably not keeping your secrets very well in that situation. So basically the same capabilities are starting to evolve in the rogue sector that have been designed in for the lawful section. So this is something that if you think about this picture long enough, you actually see that this is a complicated issue, and it also includes quite a bit of information operations that how do you should see this landscape, and what is told to be secure for you. But yeah, basically, so these slides give you some sort of example that what is happening actually inside of your consumer device networks, and how difficult it is actually to build up the security in this domain. So there are a lot of things going on here, and we just we made a decision like years back that we don't want to touch this domain, and it's like we have to be outside of these. So that is just the thing, because on the other hand, you just cannot make this secure. And what about the next slide? Yeah, you have to scroll it somehow. Yeah. So what we did. So we ended up having the own hardware, in a way that we designed it to be more like a Linux computer in that sense. So it's IMX6 based Linux computer, but the thing is that even it's the mobile form factor, it's actually the 100% of the computer. It's 100% more than Raspberry Pi or anything in that segment. But then we had also the in-house build environment for the device. So we do all of the code in our own premises, and we kind of have totally off-the-grid capability building up the environment and the image for the device, and therefore we also have the in-house code base for the device. And since we do all of these things in-house, and we utilize heavily the open source components, one of them being the Qt Linux kernel is there. We have the open U-boot in the device, and there are a lot of good options in the device sector and the software sections that we can utilize. And since we are not tied into any Qualcomm binaries, for example, it means that we can always run the latest kernel. So in the production models, we have the LTS kernel 5.4, and then we do have the 5.6 and 5.7 in the internal use. And being the latest kernel, it always gives you some benefit in the security segment. And from this forward, you can see the next slide that we also designed the hardware a bit differently. So we had a full root console access in the device, so you can plug in your serial port to find out the console in there. One of the big difference from the other mobile devices is that we do have the native 100 megabit of Ethernet, and this is something actually I kind of encourage everybody to think about, that how they would use this type of device, having the internal battery, Ethernet communication, full-blown Linux on the IMX6 4-cores and things like that. This could be really interesting red teaming platform, leave behind device or something like that. So you can plug it in the network and you can have your presence in the network through this type of Ethernet connectivity, which we have presented here. We do have the Wi-Fi as an option, and basically those are the connection options we currently offer for the device. And then the micro USB is there also, but it's only for the charging. So there's basically no data lines connected from the micro USB, and there are reasons for that, of course. And it means that the micro USB cannot reach the host, and you actually cannot access the USB, and this is the forensic security point of view. So basically, if you get the device in your hand and if it's in the wrong hands, they cannot use the USB to extract the information from the device. So these are the small details, and we just try to keep it isolated enough to keep the things secret. And then we have the couple of buttons in there and the LED indicators. And then this LEDs for the Ethernet, Wi-Fi, notification, charging, low power. It's really nice looking device when the LEDs are there, and then you can actually see that, okay, your link is up and your data is flowing, and it's a bit of the different that what you get when you buy your USB Ethernet adapter for your Android device. And do we have the next slide? So basically, this is the combination of the things. So we kind of aim to have the secure communication by having the clean hardware in that sense. So there are a lot of thoughts in how we have built the hardware. It's manufactured in Finland. We do have all the design files, and it's everything is done by us in this device in that sense. And the most important thing for the securing your communication, there is no SIM card here. So it means that we have heard a lot of questions, and always the first question is that is there a SIM card or no? So basically, when we hear this question, it's either we know that the guys who are asking it know what we are talking about, or then they don't know anything about it. So basically, if you understand what is the problem with the SIM card and the networks currently, then you kind of see that it's out of the equation when you have to do the secure communication in that sense. And on top of that, we have the totally transparent code base. It means that we have everything in here. And we can actually build up the very limited set of the components in the device, and basically the file system size currently with the Qt and our communication stack interface running, it's less than 300 megabytes. So it's really tiny, and there are a lot of space to do more with this device. And this is probably a good channel also to kind of invite the people think about that. What could be the other applications for this type of device in professional user space? So there is no Qualcomm inside, no Intel. There is NXP CPU. So it's basically very simple thing in the hardware point of view. And really, I think the whole different subject is the communication part of what we have done in the software wise in having the secure communication. But like I said in the earlier, there was no VoIP, no signal protocol, no any of that stuff involved. What we have done here, it's kind of basically built from the scratch with very different approach than what you have seen before. And one of the reason being that Arimo is actually involved of those type of project that this crypto agility is something that needs to happen, because customers are often asking from us that what kind of encryption algorithms you can have on this type of device and application stack. So we are crypto agile in that sense. In the key exchange protocols, how we do the things in the keying the communication and exchanging the keys. We do have the in-house built multi-party protocol, which is something that we are in the phase of thinking that how we move forward with that one in the public space. And this is totally proprietary at the moment, but it's very capable, totally unique approach in that sense.
Basically replacing PKI-CA model.
Yeah,
totally, and some of the weaknesses that they include also.
Yeah, so we kind of saw that the PKI model is fading, and this is something that we entered up in this space and designed something better, so to say. Of course, it's only meant to be used in this environment at the moment and these type of applications. But I kind of, it was interesting to see that the Apple did the decision to make the CA certificates. I think that they are valid 1 year in the iPhone in the future, and it kind of tells me that the whole model is broken in the CA world, and it's often difficult to find the trustworthy CA anymore. And then we do have the range of the customers who cannot share the cryptographic base. So if you have to share the secrets, but you cannot use the enemy's algorithm, then you have to find something which is in the middle ground in there. So there's a one-time pad in that sense. And if you dive into one-time pad and the usage history of that, it's the whole different story, and it's really interesting in that point of view. And then you actually end up thinking that what about the one-time pad in my consumer device? Can I have Android or iOS facilitated in my key material, and what to do with it? And you end up these type of questions that when you cannot trust the hardware, when you cannot trust the operating system storage and your computation, it's really difficult to store the key material in those devices. And what about the next? Yeah, what is the crypto agility in that sense? This is something that most of the actors and most of the people working in the InfoSec, they are kind of accepting if we say that there is a IS involved, and if we indicate that the bits are long enough, and it's getting the acceptance by that. But then there are a group of people always in who are asking that, can you do something else than the IS, for example? And this is something that I've been kind of giving this introduction most of the time by telling people that name one European symmetric algorithm, or can you name one of European hash function, or make it a bit more difficult, and can you name one Finnish algorithm for the symmetric encryption? So these are the questions that user space who are using these type of devices, they have to ask these type of questions, and believe me, there are a lot of algorithms which are not IS or Chacha or whatever there are available in the consumer space, and therefore our ideal customer for this type of product is that we can deliver the encryption in the form that the code shows here, that you can actually fill in the blanks in the cryptography when you know, because we are not the guys who can do it in that sense, but there we know that there are guys who are way better than we are. So this is the platform for those type of people, that they can drop in whatever they feel is necessary, and often I have to say it's not public information. And basically after you do it in this way, you end up on this kind of question that okay, we've been traveling with this type of technology quite a bit. Arimo been around the globe, and sometimes he's in the right place, he's doing the right type of communication, and we just witnessed the question in the public or in the closed circuit that there is something going on in the network that we cannot actually attribute. So when we are doing things differently and we are using the algorithms which are not commonly known, it means that our traffic looks like something like described here, that it's you cannot make out of it information enough that you can make a decision. So how to access the traffic, or how to classify, or how to attribute the actor. So this is actually the target of the whole thing, that clear text metadata is really interesting. There's a good friend of mine who actually dived into this problem like a year ago, and he tried to find out that where was the decision made to keep the metadata clear text in the current protocols, and there is a, if I remember right, there is an interesting gap. There is an interesting gap in the IETF mailing list where this was discussed, and all of a sudden it was agreed that the clear text metadata is something that everybody is happy with. But basically, it doesn't have to be that way, and this is something that it's outcome from all of that. And what about the next? Yeah, so I think this is so deep thing that of course we invite you guys to see us. We are based in Helsinki. There are a lot of people who have been visiting us, and there is, I think, almost everybody is welcomed. So give Arimo the email, and you are able to witness the device, all of the things that we have done by yourself, if you are interested. But you can actually believe us that when you are trying to do things differently, and when you are stepping out from that domain that everybody is actually doing, the communication security in the consumer domain, you are starting to see totally different world. You are starting to see totally interesting people, and you are facing up the totally new level of activities in that sense. And what about the next? I think that's the last one. So basically, there's a lot of going on, and my advice all to you is that don't necessarily believe that what you have in your app store is able to bring you to security, because there are a lot of things going on inside of your device. Some of them are documented and some of them are not, but most of them are used daily basis to access all of your encrypted communication. So, any questions, guys?
Okay, yeah. So I guess that this wrap ups the presentation. Sorry about the first slides, but if any questions about or some ideas about the European algorithms.
All right. Thank you very much for your presentation, and we do have questions for you. And the first one is actually about the slides.
Okay.
Can we get the rest of the slides after the talk?
Yeah, it depends how much trouble you would like to get in, but yeah, definitely Arimo can share them.
No worries, we can do
that.
that.
The first, I think we got to the train on the slide 7 or 8. So
yeah,
the first slides are missing.
Yeah.
If you could share them with us, it would be really good, and we can actually try to edit them to the YouTube talk as well. So
okay.
Congratulations, Distan, Jaroneko, because they are doing the edit, so I promised for them. Second question: how about optionally going beyond and adding wireless charging?
Yeah, basically that's all of the possibilities are there. We currently do have the aluminum case for the device, so we do have to do the modification for the casing. But since we do have all the mechanical engineering files, we can do the patch with that capability. No worries about that.
Alrighty. Jay is asking, to who is this marketed towards? So who is your customer?
Yeah, basically, so the device at the moment, it runs basically our version of secure communication, chat and voice communication. So you can do point-to-point calls with other users and chat. So this is basically everybody who doesn't trust this consumer level off-the-shelf, commercial level off-the-shelf devices. So Android, iOS, etc. So basically, we secure the communication for those guys who really think that the current platforms available are good enough, not good enough.
All righty, thank you very much. Another question. Given the in-house, in-country design and development, do you have security clearance for your product in your future for government entity use?
Yeah, not in Finland at the moment. We are working for that at the moment, but in different countries, of course, the rules are different and the security clearances are different. So in some other countries, the Western world, of course, it's more synchronized in these issues, but some other countries are not so up to date, so to say, in this kind of, so they evaluate by themselves in the organization. So there are different kind of sort of approaches for this.
Yeah, thank you very much. One more question. Then there is few more. If you have a time, you could answer them on the Discord.
Yep.
But there is one more question. Could the device have a gigabit Ethernet connection as well? Because it's kind of required nowadays, and someone is asking for that.
Yeah. Basically, you can have the gigabit Ethernet if you are willing to give up the LEDs. So basically, we are sharing the GPIOs with the LEDs currently, and if you are happy to work without the lights on the device, we can bring in the gigabit Ethernet for you.
All right. Thank you very much, guys. And we will continue shortly with the end talk by HelSec. And you guys, if you have a time, please answer the questions on the Discord. And we will later on release the talk with the slides attached to it, so it's easier to follow. Thank you very much, and let's be back in a few minutes.
Excellent. Thanks a lot.